Alright, let's start easy. So first imagine you want to expand this term. So what would it be? So the first thing you may thought is anything raised to the power of 0 is 1. So therefore this is 1. Alright, so the next level we have a plus b raised to the power of 1, and then after that you will raise to itself, which is multiplied by 1 itself, and is equal to a plus b. So now what about square? So the first thing you may thought is you multiply a plus b 2 times and you distribute it using the FOIL method or whatever. So first we have a times a, which is a squared. We have b times a, which is ab, or I'm just gonna write ba, and now we have a times b plus ab, and last we have b squared. So since BA and AB were the same, but I'm labeling them the different colors. So I'm gonna label this purple. So we got a squared plus, we have a squared plus 2ab plus b squared. Alright, so let's move on to the cubic term. Even though this is a pattern, good job. If you haven't noticed, well, I wish this time you could. So now the same thing. But now I'm gonna multiply everything by 3 times though. I'm just gonna copy this thing because this is like a plus b squared, right? So we have a plus b squared multiplied by a plus b. So the a plus b cubed is actually, I'm just gonna copy this into here, this into here, right? So I'm gonna make it purple. A squared plus 2ab plus b squared. I'm even gonna keep the term too, like the ba plus ab plus b squared, and finally multiplied by the a plus b. Alright, very cool. So let's do the distribution. So we have everything multiplied by a, so result in a cubed plus ba squared plus a squared b plus b squared a, and plus now all the a terms multiplied, now the b terms, plus a cubed, a squared b plus b squared a plus ab squared plus b cubed. So what you might notice is it's kind of messy here, but I'm going to label the like terms. So let's find that which have the term a squared b. So we have 1a squared b, 2a squared b, 3a squared b right here. What about b squared a? We have 1, 2, 3. So this is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. So you might notice that, so the first thing you might notice is why there are three, why there's three, why there are like three multiples of b squared a, and there is 3a squared b over here. And you might notice is the first power is always equals to all the powers combined. So we have 3. So even though it is only 3, yeah, even though this is only 2, but b is a power of 1. So 2 plus 1 is equal to 3. And this applies to all the same, applies to all the things. So why actually? Well, if you notice from the a plus b squared, what we did is we multiplied the b times a and a times b. They may look the same, but theoretically they multiply by the different order. Means the b is multiplied first and the a is multiplied first, and we just combine them together. So if we actually write this differently, what we will get is this. So based on what we just multiplied by now, so I'm not gonna multiply everything again. I'm just gonna do this. So you see, we have BA, A multiplied by A. So we have BAA. And then AB plus ABA. And finally, B squared A, which is just BB. So plus BBA. And this A cube is, what, A cube. Alright. So plus, again, I'm gonna label this what color? Maybe light blue. Yeah. So now the b term. So the b cube I'm not gonna write because it's, so we have AAB, we have plus BAB, I'm currently multiplying by, I'm multiplying like this. Yeah, that's what I'm doing all along. So now I'm multiplying by the ABB. So we have ABB. And finally we have the b cube. So now as you can see, this is even more confusing and more long, isn't it? But it's okay. We will see the pattern together. So now let's actually change this, because this doesn't belongs to here. So I'm just gonna do a little, yeah, I'm just gonna do this. Okay, so I want you to notice one thing. Pay attention to how many letters this have. So look at this region. We have 2 A's, 1 B. Alright, so we have 2A and 1 B. And this over here, we have 2 B and 1 A. So what are all of this? You see, the B is in the first position, and the second, the B is in the second position, and the third term, the B is in third position. So what this means actually, it means that we are trying to combine between the 2A and 1B. So what this tells us, what is the number of combinations we have if we chose 2 terms, if we have 3 terms, and we have 2 terms repeating. So it will be 3 factorial over 2, which is 3. This is like 6 over 2, which is 3. So this will explain why this 3 is here. Same to this thing. You have 2 B's and 1 A's. So what is the possible combinations we can do is, so the same thing, we have 3 items, we have BBA, and we have 2 repeated B's, and this will result in 6 over 2, sorry, 6 over 2, we will get 3, which explains the 3 over here, right? So why the BQ don't have any term? Because it only have one combination, which is BBB. No matter how much you arrange the BBB, it will only have one combination. So this is like 3 factorial over 3 factorial. Yeah, so it's just 1. Okay, so very interesting. We just discovered something that related to combinatorics, which is unexpected. But here's what's important. We need to know what is the relation for higher powers. So what about a plus b power 4? Well, we will need to expand all over again, but if we can discover a little bit something from the previous one, we might discover what is it. So this might be well, this might be all like it's been a draft here. So alright, let me think for a while. Okay, you know what? I'm just gonna like expand the 4 power. So yeah, I'm gonna expand the 4 power, but I'm not gonna expand one by one. I'm just gonna write the answer. It's going to be a power 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b power 4. Alright, so what can we do from this? What can we extract from this thing? Well, the same thing. We're gonna pay attention to what? We're gonna pay attention to the 4ab cubed over here. So what are the possible combination we can do with 4ab cubed? So what causes this 4 actually? So we have like a b. So the b can get where? The b can only have like 1, 2, 3, 4. So we can a b. We have a b a. Let's just start from the first one. So we have b a. We have a b a, and we have a b a. Then finally we have a b. So this is like 4. This is not just similar to the 4 factorial over 3 factorial, but there's something related to, yeah. So the 6a squared b squared. So the reason why 6 exists here is similar to what we have in the AB, but it's a square. So let's discover all the 6 combinations. So we have AABB, AABB. So where did 6 come from? We don't even need to list all of this, we just need to know where the 6 come from. So we have 2 items, we have 4 items, so we have 4 factorials. So this is actually like 4 factorial, and we have 2 similar items. So this is 2 factorial, 2 factorial. So what we can see here is we have 24 divided by 4, which is 6. And this is also the same. So if each term, how can we relate that? How can we discover what causes the number to change? Why is here 4 and here is 6? It depends on the number of A's or number of B's, but clearly we need to know the number of A's. So what have we discovered so far actually? We discovered that the coefficient is actually determined, it's actually a combinatorics. It's not a combination, is numbers of ways to arrange. So this number of ways to arrange, and and also it also depends to the number of a's. So if we have 3a, if we have 4a at the start, we have 4 items. So yeah, we have 4 items, and when we have this term, we have 3 a's and 1 b, and at this term we have 2 a's. Yeah, okay, let's actually explain this term very clearly. So I'm gonna move all this. I'm gonna copy everything from here. No, right, copy. Oh my. All right. All right. I hope you already get something here. Yeah, it's very obvious. I'm just gonna clarify. I'm gonna clarify that from this we have 4 items, and we have 4 factorials. We have 4 the same items, so 4 identical items, so divided 4 factorial. So this we have 4 items, 4 items, 4 items, 4 items. Yeah. So, but now we have 3 a's and 1 b. In this case, we have 2 a's and 2 b. And from here, we have 1 a and 3 b. And from here, we have 4 b's and 0 a's, whatever. Yeah, 0 factor is 1 if you don't know that. Well, I'm just gonna give a quick explanation so we know that n is n times n minus 1 factorial is equal to n factorial. So you sub 1, you have 1 times 1 minus 1 factorial equals to 1 factorial. No, this is 1, so this is just 0 factorial equal to 1. Yeah, whatever, that's that. Okay, so what am I notice? So you see, these two numbers add up to 4. What even amazing is, there is a pattern that explains it. So if this, so now let's assume that we have n items. So assume that we have a power of n. So now if the coefficient have k numbers, so let's say we have k n's. Yeah, so like let's say like a power 4b. Yeah, let's say we are expanding, yeah, something like that. So we have n powers, and then we have the number of k. So the number of a is 3. So we have k, but I'm not gonna write it 3. So except we have k number of a's. So what's the number of b we have? We have n minus k factorial. Why? Because we have k similar items and n minus k similar b's. So this is the similar a's. This is the similar b's. B's. All right. So what is this? Clearly, this is n choose k. What amazing is, yes, this is n choose k. This is so amazing, right? Oh fuck. Right. This is amazing, right? So we n choose k. N choose k over here. So yeah. So we have n choose k. And this explains the term, all the term we have. So this k represents the number of terms your a have. So let's rewrite the a plus b power 4, shall we? So we have a plus b power 4. We know that we will have a power 4 and an unknown number. We're gonna fill the blanks together. So we have a cubed b plus blank a squared b squared plus blank ab cubed plus blank b power 4. All right. So what fill in the blanks actually? So you see, we have four terms. We have four A's and we have zero B's. So that's 4 choose 0. I mean, that's 4 choose 4. We have 4 A's and 4 identical items. So there's 4 factorials. And from this case, we have 4 items and we have 4 minus 1 identical items. So we have like 3 A's over here. So we have 3 A's and 1 B, and that B is the thing. At this case, we have 4 items and we have 2 similar items. But if you said that we have two similar items, then why this only one is not 2? Well, actually, the combination doesn't depend on the permutation actually. So the 4 choose 2, you're actually choosing either A or B. So if you're choosing A, at the same time you're choosing B. So that's why we only have 4 minus 2 and not twice. So not twice the combinations. So from here, we have 4 items and we have 3 similar 3 B's, so we have 1 A's. So this means that we have 4 factorial divided by 1 factorial times 3 factorial because of the B. So we have 3 B's over here and 1 A's. And this, you know it. So what we observe here is a beautiful pattern. We have a beautiful pattern here. So A plus B. So we have A plus B power 4 over here. We have 4 minus 1, 4 minus 2, 4 minus 2, 4 minus 4. So let's generalize this, can we? So let's say I want to write about A plus B power 5. Clearly we already know what this means. So we just need to write the term A pi power 5, A4B, and plus A cubed B squared plus A squared B cubed plus AB power 4 plus B power 5. So the same thing, let's fill in the blanks. We have 5 A's. I mean, from the 5 items, we have 4 A's. And the 5 items, we have 3 A's. From the 5 items, we have 2 A's. From the 5 items, we have 1 A's. And from the 5 items, we have 0 A's. So what interesting is we can generalize this formula. So this is called the binomial. Finally, this is called the binomial theorem. What is the binomial theorem? Among what the 23 minutes we just did just now, we are trying to express the binomial theorem by finding the terms logically. So we're not just finding just memorizing formula. We're discovering like why this actually happening. So I'm not gonna write all the things. So if you know binomial theorem, you should know series because it's kind of a class 12 or grade 12 thing. So let's just generalize it. So A plus B power n. So this is the actual binomial theorem. I'm not lying. So this is the actual binomial theorem. So we have the sum of r equals to 1 to n. And we have n choose r. I'm sorry. So we have A plus B here. A power n, B power n minus r. Am I right? Oh no, this is A power r. a power n minus r and b power r. Yeah, because as you can see, the top will always sums to n, which is 5. The number of term is 5. Yeah. So the number of term is 5. Similar to everything we said from here. So you see we have 5 here. We have 5 plus 0 because 1 is a power 0. And we have 4 plus 1, 3 plus 2, 2 plus 3, 4, and 4 plus 1 and 5. This all equal to 5. So this is the binomial theorem, and the NCR, and then the NCR represents, this is the N. This is actually the this is NCR, but most people love to write it like this. So this is called I forgot what it's called. Maybe it's the permutation. Oh, no, the combination. I forgot what it's called, but whatever, you know it. So now we know that. Now we already know. We just discover that when we have a plus b power n, we would have. So this is so let's say we find a term. So whatever, and we have a term here. This term, what is the coefficient of this term? So let's say alright. So let's say we have a plus b power 7, right? So I want to find what is the coefficient of the term a power 4 b cubed. So you already know we have 7 factorial, and we choose 4, and we have 4 a's and 3 b's. So what is this? We have 7 items. So if we write this in terms of this combination thing, we have 7, and this is the number of a's. So the answer is 7 factorial over 4 factorial 3 factorial. Yeah, and I'm gonna calculate for you. So we have like 7 times 6 times 5 times 4 factorial, and this is 4 factorial times 3 times 2 times 1. Oh wait. So this cancel out, this cancel out. So we have 35. So the term a power 4 b cubed is 35. So from this video, I hope you already know what is the meaning of binomial theorem and where did it come from. I really thank you all for watching. So if you have any question, feel free to ask me. So yeah, goodbye.